Hi there. In this video, we're going to be talking about adding integers. If you want to add integers, the most important thing that you've got to keep in mind is what we call the zero principle. Zero principle basically means that if I have a positive number, like 1, and I have its exact opposite, the negative number of the same value, so negative 1, those two numbers will always equal 0. So for example, if I have positive 5 and I'm going to add it to a negative 5, it's going to equal 0. And it makes sense if you think about it. If I have 5 of something and I have negative 5 of something, which means I'm taking 5 of something away, 5 take away 5, that's going to equal 0 every single time. That's going to be important as we look at using counters to help us with these next questions. You can illustrate the zero principle by looking at counters in place of your numbers. So, for example, the model I have here is one red counter, a positive, and one blue counter, a negative. They stand for positive 1 and negative 1, which means that when placed together in a pair, they also are equal to 0 because they literally cancel each other out. That's going to be important when we look at our next examples. Our first example is going to be a negative number plus a positive number. In this case, negative 3 plus positive 7. Now you can probably guess that because 7, the positive number, is larger than 3, the negative number, my answer is probably going to be a positive number. But we should check and make sure that we know what we're doing. One of the ways we can do that is by using those same counters to model. And here they are. So as you can see, I've modeled negative 3 with 3 negative counters and positive 7 with 7 positive counters. So essentially what I'm doing with these counters is repeating the equation negative 3 plus positive 7. Now, the way I can think about it is, as I said before, each positive and negative counter, when paired together, actually adds up to 0. So the first thing I want to do is eliminate all my pairings of counters and see what I have left over. So for example, I can take this counter and place it with that one, that's a pair. This one and place it there, that's a pair. And this one, place it there, that's a pair. Now once again, as I said, these two counters, when placed together, are like saying negative 1 plus positive 1. They cancel each other out and they give me 0. So that's worth 0, that's worth 0, and that's worth 0. These counters over here have nothing to pair with. So I can literally count them 1, 2, 3, 4, and I note that they are all positive numbers. So my answer is positive 4. In this example, we're taking a look at a positive plus a negative. Once again, my positive number is larger than my negative number, which would lead me to believe that my answer will be a positive number. Let's check and see if we're right. In this case, I have 6 red counters to show my 6 positives and 4 blue counters to show my 4 negatives. So, once again, I'm going to pair them off. 1, 2, 3, 4, until I have no pairs anymore. I'll cross those out to give myself a little bit of a reminder, and I'm left with 1, 2 red counters. That means that my answer is positive 2. So this example is a little different because I have a negative number plus another negative number. The other two examples I had positives and negatives intermingling. In this case, I just have 5 negatives plus 3 negatives. As we've said before, I've demonstrated that with my 1, 2, 3, 4, 5 negative counters plus 1, 2, 3 negative counters. In this case, the zero principle doesn't come into play because I have no positive counters to pair up with my blue negative counters. In this case, I can literally just count up the number of negative counters I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. Since there are no red positive counters to block any of these out or cancel them out, then I literally do have negative 8 as my final answer. Now this one's too easy for you guys, but just to make sure we covered all our bases, I thought I'd take a look. This is when I'm adding a positive to a positive. And while that might be confusing for just a second, it's literally the kind of adding you've been doing since you were small. This really is the same as writing 3 plus 2, because when I see 3 and 2 without any sort of sign beside them, I know automatically that they're positive numbers. That's what we've usually worked with. So we know that the answer is 5, and that since we're working with integers, we'll write it as positive 5. Can we show that with the counters? Sure we can. Just like the last question, I've got all positive counters, no blue counters to work with the zero principle. That means I am just literally going to count up 1, 2, 3, 4, 5, the number of positive counters I have, and sure enough, as you guys already knew, the answer is positive 5. So remember, when you're using adding with integers, don't be afraid to use those little counters as a hint to sort of help you work out your numbers. Pretty soon, you'll understand the numbers well enough that you won't need them. But it's a great way to start when you're getting used to it. And they're easy to draw and quick as well, so keep that in mind. All right, happy counting.